Good morning, good afternoon. It is a pleasure to be here. This is a beautiful picture. It was created by Box.com in 2014 as part of the research about information flow in different organizations, different industries. This specific image is about a typical large construction organization. We'll come back to this image later because it illustrates the challenges we have in the construction industry. But before we dive into the details, I would like to present Trimble, a global company with 11,000 employees, about $3.2 billion of annual revenue, and 4 industries that are our main focus: transportation, agriculture, geospatial, and construction. Trimble develop hardware and software solutions. On the hardware side, think about GNSS technology, positioning technology, reality capture, things like laser scanners and total stations, IoT devices and sensors, and machine control. On the software side, it is typically end-to-end solutions to the industries we serve. So if we'll take construction, for example, we have design solutions like SketchUp and Tekla structures. We have construction management applications, and we have owner's portfolio solutions. A core value for Trimble is to deliver integration. Integration of hardware, integration of software solutions, and integration of business processes for our customers as a mean for efficiency. And this brings us back to the image we started with, but this time with some references. On the bottom right, we can see a typical organization in the finance industry, very centralized information flow. And then on the top right, we see manufacturing with a bit looser structure. And then on the left, the chaotic construction industry. Now, if you think about it, it's a natural path. It's a natural structure because construction is a local industry. We have local owners, local authorities, local regulations, subcontractors, contractors, manufacturers. They're all local. And the project can be anywhere around the world. So we cannot change this structure. We might be able to offer prefab as a partial solution. But what we can do is we can utilize technology and create a digital transformation process that will help us take the efficient information flow that we see on the bottom right and implement it on top of this fragmented construction industry structure. And this change can transform a complete efficient process. Now, some of you might ask why this will work today. We are all familiar with those graphs that you see on the screen about the productivity of the construction industry. There is no need to read the small letters. Always follow the red line at the bottom. With some optimistic scenarios, it will be a flat line. With more pessimistic scenarios, it will just go down and increase the gap compared to the other industries. So why we think things can happen differently at this stage? A possible answer for this question is enabling technologies. And to be more precise, exponential improvements in enabling technologies. And we can talk about 3 technologies that you can see here on the slide. Computation power is the first one. It's the ability to consume and analyze a huge amount of data that is needed to get decisions in construction. The second is broadband speed. Remember this image we presented with all the remote sites. In order to make decisions, we need to make sure that decision makers can get the data from the site in real time. And the third is about data volume, big data. We have enough data today to utilize AI and machine learning to make insights, predictive insights, and even prescriptive insight to improve the decision-making process. So once we have those enabling technologies, we can start to look at more specific technologies. And what is important here is not to look at each of them as a single specific technology, but to look at them as a whole. because once they work together, we can deliver efficiency. Take a look, for example, at BIM, but not the lonely BIM, but a collaborative BIM, a cloud-based BIM solution to improve communication and transparency. Or mixed reality, which brings together the digital and the physical world to improve the ability of users to understand the relation between the two environments. Robotics for automated workflow, brain-computer interface to improve the interaction between humans and asset, digital and physical. And of course, AI with its ability to predict and prescribe solutions. So when we are talking about integration, we should look at it from horizontal integration and vertical integration. On the horizontal side, supporting the full workflow from design to construction to facility management. And on the vertical side, support all stakeholders, ensuring that data flow is effective and support the decision-making process. And it's not just about the horizontal and vertical integration, it's also about integration of business workflows. Those are critical for a successful integration and implementation of the technology. As an industry, we are great with collecting data on site. We have GNSS, we have drones, we have IoT sensors, cameras, robots, humans collecting data. And we have the cloud infrastructure to absorb the data and process it, and then the edge solutions on finance and operations and logistics to really help decision makers do their work. What we should improve is the linkage between the different stages. We should automate the data flow in order to get real efficiency and real transformation of the industry. And I would like to give you two examples. The first one is about a four-legged robot equipped with a reality capture device, a Trimble scanner, collecting data and uploading this data to the cloud. What you see here on the screen is a Boston Dynamics Spot robot with an integrated solution to capture data in a construction site. Once the robot finishes the collection of the data, it will move to the next waypoint completely autonomously, and the data will be uploaded to the cloud. So decision makers, designers, owners, anyone who involved in the project can actually visualize the progress on site and understand and take decisions based on the input from the site almost in real time. We can take this concept further and start evaluating the data we collected and compare it to additional information. For example, compare it to a BIM model. On the screen now, we see a use case from Hensel Phelps, a strategic customer for Trimble. And in this project at the Denver airport, a renovation project, they took the scan data collected by the robot autonomously and compare it to a BIM model to identify any discrepancies between the two early on in order to avoid delays in the project later down the road. Another great example for integration is mixed reality. And in this case, we bring together the BIM digital content and the physical environment, and we place them aligned to each other so on-site construction workers can evaluate the relations between the two and identify any discrepancies or deformations. This information can also be shared with remote users, and actually we can offer them the opportunity to completely immerse themselves in a remote site and understand the situation in real time. Those two examples present not just integration of hardware and software or business workflows. It represents an integration of the industry as a whole, from the design to the construction to the facility management stages. And this is where we can bring efficiency and transform the industry. A successful implementation of mixed reality can take us farther with AI. Using AI, we can create semantic models, better understand the environment, and actually reflect this by presenting delays in schedule or discrepancies from design in a visual way. Successful digital transformation and kind of holistic view that we presented here can really make a change, can deliver efficiency with improved productivity, transparency with all stakeholders engaged and involved in the process and have access to data. Traceability, a critical aspect if we are talking about improvements. Traceability can provide me the ability to go back in time and see where decisions were made and learn to do better in the future. Interactivity, the ability to simulate, to run what-if scenarios. What if we change the structure from concrete to steel? What will be the impact on the cost? What will be the impact on the schedule? What if we change the compactor pass? How efficient this be from the fuel consumption point of view? Predictability, and even take it further, prescriptability, the ability of the system to deliver solutions to the decision makers. And last, but maybe the most important aspect, sustainability. It is our responsibility as an industry to improve sustainability, to reduce the carbon footprint of the building environment. A successful implementation might help us as an industry to change the the image of the industry from a technology follower to a technology leader and improve productivity dramatically. Thank you very much.